Okay, guys, we've reached the final topic. This is topic number 5 on graphing polynomial functions. And you know, at first thought, you didn't really have much to add here because I feel like we've already touched on everything that we needed to. But then I thought about it some more, and I guess I'll just share with you my personal way of graphing, how I approach these things. And then after I decided that, I looked into the book, and the book actually does something pretty similar. So here it is. First of all, when I graph a polynomial, I look for what the roots are, the real roots. And this might mean having to factor if it's not already factored. Fortunately, the questions that we're given, they're actually factored for us already. Although we did do some factoring in earlier questions. And then plot those roots on the graph. That's the first step. You're going to plot those roots, which are the x-intercept, right? And then if you want to, you can also plot the y-intercept. This is kind of, to me, optional, but you can do that. And it's pretty easy to get there. You just plug in 0 for x, right? And then third, I think about the left end behavior. The left end behavior. Because that's going to tell you how you should approach the first root, whether you should be coming from the bottom or whether you should be coming from the top, right? As you're approaching that first root. And then what you do is you smack that first root depending on the multiplicity. So either you're going to go right through it or you're going to hit it and turn around, right? You're going to just touch it or hit it, depending on if it's odd or even multiplicity. Okay, and then you just repeat that process for each root until finally you hit the last root, and then at the end, make sure that it just matches whatever your expected right end behavior is. You could actually get by without doing the right end behavior based on just the multiplicity of the roots and whether it goes through or not, but you should just double check and make sure that you're matching with what you expect the right end behavior to be. Okay, so that's the process. We're going to answer the last 5 questions. I have them copied and pasted down here. And along the way, there's a bunch of things that they ask us to do. So like steps A through G. All right, let's start with number 13. Okay, so here's our polynomial function here. And first it's asked to describe the end behavior. Now, describing the end behavior, remember, depends on the leading coefficient and the leading term. And to get that, when you look at something like this all factored out, right? Your first thought might be, oh shoot, I have to like multiply the whole thing out to get the leading term. But there's a little kind of sneaky way around it. You don't really have to know the whole result. You can just focus on first if there's any number in here and then any values of x. So here I have an x, I got a negative x, and I got another x. Also pay attention to if there's any squaring going on or anything like that, but in this case there is none, so I don't need to worry. So the leading coefficient is going to be the result of taking negative 2, that first x, that negative x, and that other x, and whatever that result is, that's going to be the leading term. So I've got a negative 2 and negative x, that's going to give me a positive overall. And I've got 3 x's, so it's going to be x to the third, 2x to the third. This is your leading term right there, which means as x goes to negative infinity, this is going to be negative, right? And 2 times negative something is going to be negative. So y is going to go to negative infinity. As x goes to positive infinity, everything's positive, so y is going to go to positive infinity. So that's part A done. Okay, moving on to part B. Find the real zeros. That's actually easy to do because it's already factored for us. So I just focus in on here. What are the different terms? And then figure out my zeros from there. So x is negative 1 would be the first one. X equal to 2 would make this second one 0. And then x equal to negative 4. Okay, on to step C. Determine where the graph is above and below. I'm going to actually revisit this in the graph. So we're going to skip this one for now. Kind of just pass by this one for now and then come back to it. And then let's go on to letter D. Determine the y-intercept. Y-intercept, remember, is where x is 0. So just plug in x equal to 0 in my original function. So negative 2, 0 plus 1, 2 minus 0, 0 plus 4. If you want to, you could use a calculator, but this is easy enough. It's 2 times 2 times 4, which is 4 times 4, which is 16. And it's negative because there's a negative in the front. So negative 16, that makes my y-intercept 0, negative 16. Okay, then on to letter E, identify any symmetries. Remember, symmetries, in particular, we're looking for odd or even symmetries. And let me just tell you, though, most likely none of these are going to have either one. Remember, even symmetry is when f of x is equal to f of negative x, I mean. And odd symmetry is when f of x is equal to the negative of f of negative x. So to determine that when something's factored like this, like if it's not factored, it's really easy to tell because you can just look at it straight on. But if it's factored like this, you got to kind of plug it in, manipulate it slightly. But I'll tell you right now, it's like very unlikely that any of these would follow this pattern, just because of the way things work. You know, another way that you know if a polynomial in particular is odd or even is you just look at the powers. Are they all odd? Then it's an odd function. Are they all even? Then it's an even function. Even functions have even symmetry, or symmetry across the y-axis, right? And odd functions have symmetry across the origin. Okay, so let's do a quick check though. How are we going to check this? So what is f of negative x in this case? It would be negative 2, negative x plus 1, 2 plus x, negative x plus 4. And just by inspection, I can tell This is obviously not equal to the original f of x, and it's also not the negative of this, because if it was the negative, then these guys should just be, this should be a positive 2. It should have been x plus 1. Everything else should have been the same, right? If it was just the opposite. The only thing that should have changed is the sign in the front. And otherwise, everything should have been the same. So it's neither type of symmetry. So no symmetry. Okay, and then that same thing is going to happen for basically all of them, I think. Okay, f, identify the maximum number of turning points. So our degree was 3 for this, right? So 2. So I'll say less than or equal to 2 turning points. That's letter F. Okay, letter G, sketch. Okay, finally we get to the sketching part. And along the way, we'll answer C. I'm going to just include the sketch as the answer to C. Okay, so finally we get to the sketch. Here we go, guys. Let's draw our axis. And remember what I said when I graph my polynomials, my first step is to just look at my roots, my zeros. -1, 2, and -4. And plot those things. So -1, 2, and -4. 2, 2, 3, 4. 1, 2, 3, 4. Right there. Yeah. Okay, what's the end behavior? End behavior to the left is negative. So it should approach that first thing negative. And remember that is a, these are all single multiplicity. So I forgot to write this, but this is a cross. It crosses, and it crosses every single time. So it crosses through, let's do our graph in red. Crosses through that first point, turns around, crosses through the second one, turns around, crosses through the third one. Now we ask ourselves, does that match the right end behavior? The right end behavior, it should go upwards, and this is going upwards. So yeah, checks out. There you go. Simple as that. Yeah, pretty easy. Okay, pretty easy, but it was a little bit long, tedious. Yeah, I know. Okay, number 13 down. And the rest are going to be super similar, I think. I see, looking ahead, looks like there's some roots that have multiple, different multiplicities. And so that would make things slightly more interesting, but otherwise, it's all pretty much the same. Okay, here we go. So doing question number 13 down, onto number 14. Okay, so end behavior first. First, we got to determine what is my leading term. So I've got a negative x squared, I've got an x, and I've got an x. So that's going to be negative x to the 4th. This is my leading coefficient. Leading term, leading coefficient. The leading coefficient would be -1, yeah? Okay, so that means as x goes to negative infinity, this thing's going to be positive when it's x squared, but then negative, so it's going to be y goes to, oh, that's a terrible y. Y goes to negative infinity. Okay, as x goes to positive infinity, y is also going to go to negative infinity. Okay, that's part A. Part B, real zeros. X is 0, x is -1, or x is 2. This one, multiplicity 2, so it touches, and these two crosses. Okay, letter C, so we're going to skip for now, right? And then letter D, y-intercept, okay. Y-intercept, just plug in 0. It's going to be 0. Oh, okay, this makes it easy. Times 0 plus 1 times 0 minus 2. That's going to be 0 because you're multiplying by 0. So the y-intercept is 0, 0. Oh, I just remember I forgot to plot it last time. Sorry, guys, but yeah, you still got the sketch. I'll remember to plot this time. Okay, E, any symmetries? So real quick, f of negative x, that would be negative of negative x squared is still x squared. That'll be negative x plus 1. So that already not matching. It should have been x plus 1, negative x minus 2. So that is not working. Okay, so no symmetry. It doesn't match the original, and it's not the negative of the original either. And now on to F, maximum turning points. Maximum number of turning points is going to be, so the degree was 4, so it should be less than or equal to 3. And then finally the graph. Here's the graph. There you go. X, Y. This time let's plot also our y-intercept. Y-intercept was at 0, 0, so that's nice. And we also already had that actually in this case. -1 is another one. And +2. Okay, and then left end behavior, it should approach from the negative side. And the smallest one is -1, so it crosses through there. Yeah, crosses through -1. So it approaches -1 from the negative side. And then at 0, it's just a touch, right? So it should go through at -1, touch at 0, and then it's going to turn back around to hit that last 0. So now what was end behavior? End behavior should be negative on the left, negative on the right, and that checks out. Yeah, check. So everything looks good. There it is, just a sketch. Oh, yeah. I was gonna say, oh, I forgot the y-intercept again, but I did hit the y-intercept because the y-intercept happened to coincide with an x-intercept in this case. And it looks like for number 15, same thing's gonna happen because I have a x term out front. So that's gonna mean it's gonna cross 0, 0 again. Okay, 14 done. 15. Okay, first leading coefficient. I've got x squared here. And here I've got an x, but it's ending being squared. So when if I was to take x minus 3, square all those things out, I'd end up with an x squared term. That'll be my biggest term. So it's x squared. And so combining those, x to the fourth is going to be my overall leading term. That means as x goes to negative infinity, y is going to go to positive infinity. And as x goes to positive infinity, y also is going to positive infinity. It's going to look similar to x to the fourth in that regard. Okay, that's part A. That's part A. Okay, part B. Find the real zeros, x equal to 0 and x equal to 3. And both these cases are multiplicity 2, so these are both touches. Touches. Okay, letter C. Where is it above and below? Well, just see the graph. Yeah, just refer to the graph. And if you want to, you can plot out those intervals based on what you see in the graph. Okay, where are we now? D, y-intercept. Okay, y-intercept. Plug in 0. I got 0 squared, 0 minus 3 squared. It's going to be 0. So the y-intercept is 0, 0. That's what we said earlier, right? We said it was going to be that. Letter E, symmetries. F of negative x is going to be negative x squared. It's still x squared. And we got negative x minus 3, which doesn't match because it should be x minus 3. And then the negative should come out to the front. So, yeah, not the same. No symmetry. Okay, and then, what was it? F, maximum number of turning points. Easy question. There should be less than or equal to 3 because the degree was 4 for the polynomial. Okay, finally, we're ready to graph. It's letter G. Okay, here's x, here's y. Okay, so start by plotting our zeros. I got 0 at 0 and 0 at 1, 2, 3. Okay, and both of them have multiplicity 2. Left end behavior, I should be going to positive infinity, so it should be going up in that direction, right? So I should be going up, touch the graph, and then just touch the graph again. So something like this. Okay, looking at that, does the right end behavior match? Yes, it should also be going towards infinity, and so across the y-intercept as well. So everything checks out, and yeah, you're good. That's 15. Okay, two more. We're out of here, guys. Almost out of here. Okay, here we go. I guess I'm not gonna. Okay, 16. Okay, we got a big ugly monster thing looking here, but don't worry, it's not as bad as it looks. We got x. I've got x, but it's gonna end up being squared. So here, let's just write things out. X squared. Next, I've got another x, but this one is gonna end up being cubed. So x cubed. And here I have a negative x. So it should be negative x. Okay, that's gonna make my leading coefficient. Let's say I got 1, 2, 3, 4, 5, 6, 7. X to the 7th with a negative in front. That means as x goes to negative infinity, this guy's going to be negative, right? Because negative power with an odd power, negative number to an odd power is going to be negative. But then turn it negative again, it's going to be back to positive. So y is going to go to positive infinity. But what about as x goes to positive infinity? Well, y is going to go to negative infinity in that case, because this will be positive, but then take the negative of it. So that's part A. Okay, part B. Real zeros, easy. 0, 1, multiplicity 2, negative 4, and 5. Those are the things that will make it 0, yeah? Let's count the multiplicities. This one is even multiplicity. And so that means it's going to touch here. And the rest are odd, right? So these guys are this one, and this one. Those are all going to cross. Okay. Now to letter C, we said we're going to just show in the graph, so skip down here. Letter D, determine the y-intercept. Sorry, using a different color scheme, I think, than the last time. Y-intercept, this is going to be f of 0, but there's a 0 term in there, right? So it's just going to be 0 again, and I get the origin again as y-intercept. Okay, nothing too exciting there. E, any symmetries? F of negative x would be negative x. Okay, that's looking promising, but No, then I get negative x minus 1, and then everything is messed up already. Negative x plus 4 to the third. Nope. 5 minus, 5 plus x, actually. So this is not looking like the negative of the original fx. Definitely not the original fx. So, yeah. I know you might be thinking to yourself, well, can't you like factor out a negative here and then have this being x plus 1, right? And then have a negative out here and then squares, so doesn't that start to look correct? But the thing is, that's not going to be the right factor because I have x plus 1, but this should be x minus 1, right? So you see how it doesn't work? So that's not symmetric. If you're not sure though, if you're kind of suspicious that it might be, what you can always resort to is multiply that whole thing out, which is actually, that's a big ugly monster. But you could, and you notice that you have a mixture of odd and even powers, which makes it neither. You also notice that it's not the exact opposite of the original. Okay, so that is letter E, and let's letter F. Letter F is the number of turnarounds. It's going to be less than or equal to 6 turnarounds because the power was 7. And lastly, letter G. We're doing 2 in black in a row because I feel like the graph should be black. At least the axes should be black. Okay, X and Y. And start by plotting our zeros. So our zeros are at x equal to 0, x equal to 1, negative 4, 1, 2, 3, 4, and positive 5. 1, 2, 3, 4, 5. So those are the x-intercepts. We got the y-intercept here as well already. And now we look at our end behavior. To the left, y should be positive. So I should approach that first one. Let me label these guys because there's so many of them. So I should push that first one and cross it. Yeah, first one is crossing at negative 4. So cross it. The only one that touches would be the 1. This is the one that touches at 1. So it should cross the negative 4, cross the 0, touch at 1. That means it's going to come back around to hit 5. And sorry, my hand is a little shaky, but that's the general shape of it. Okay, so let's check our end behavior. Does that match up? And does it match up all we said? So it touched at 1. Okay, the others it crossed. End behavior was negative, and that matches. End behavior on the left was positive. So yep, everything looks good. There it is. And one more to go. So yeah, plotting polynomials, at least especially when they're in factor 4 already, then really not so bad, right? And if it's not factored, then we do what we did back in, there's a couple questions where we had to factor to find the zeros. So we'd start with that step first and then carry out the rest of the steps. Yeah. Okay, guys, we're at the last question. All right. Number 17. Okay, so here's our thing. Okay. So now what do we have for the leading term? We've got an x squared. We've got an x that is eventually squared and x that's eventually fourth. So we've got x to the second. We've got an x to the second again and an x to the fourth. Sorry, that looks like I don't know. That should be a 2. Okay, so 2, 4, 8. Yeah, 2 plus 2 plus 4 is 8. X to the 8th. That's my leading term. No other numbers or negatives to worry about. So that is what it is. As x approaches negative infinity, y approaches infinity. As x approaches positive infinity, y also approaches infinity. That's letter A. Okay, letter B. Real zeros. Okay, x. Oh, okay. So let's take a look. Real zeros. What are the zeros? First of all, x squared plus 9. That guy has got no real zeros, right? Because why? Because there's nothing that you could plug in for x that's going to give you a negative 9 to make this 0. So there's no 0 there. This one, x minus 3 squared, that gives you a 0 of 3. And then this one gives you a 0 of negative 1. Yeah. And both these have even multiplicities. So that means these are both touches. Both touches. Okay. Okay, yeah. You see, we're going to skip for now, like we always do. So actually, let's get rid of that. D. I'm not, I say skipping C, but really I'm showing C in the graph, right? And then if you wanted to, you could go back and you could track the intervals if you wanted to. Okay, determine the y-intercept. Okay, that's f of 0. It's going to be 0 squared plus 9, 0 minus 3 squared, 0 plus 1 to the fourth. That's going to be 9 times negative 3 squared is 9 times 1 to the fourth is 1. Okay, 9 times 9, so it's going to be 81. So 081 is the y-intercept. Pretty high number there. It's going to be kind of hard to graph, but whatever. Okay, symmetries. F of negative x. That's going to be X squared plus 9. Okay, so that part's looking good so far. But then I'm going to get a negative x minus 3 and the whole thing falls apart. Okay, so none. No symmetries. It doesn't match the original f of x or negative f of x. Okay, f. Oops. Sorry, wrong color. Switch colors. F. There's less than or equal to 7 turning points. And finally, letter G. Let's graph the thing. Okay, I know I need to go to 81, so I'm going to miss some space to do that here. This is, of course, going to be really inaccurate because 81 is so high for my scale here. Okay, but anyway, plot the zeros. I've got one at -1 and one at 3. -1 and 1, 2, 3. Okay. Yeah, I know my y-intercept is like way up here somewhere, actually higher than that, but it's like way off my graph, so I'll just go to the highest point on my graph. Okay, and I know that I should be just touching both intercepts, and I also know that my end behavior on the left and on the right should both be positive. Okay, so I should be hitting this from the positive direction, and then I should go way up all the way to 81. Actually, yeah, hitting from the positive direction, go way up to 81, and then probably pass through, and then come back down to hit that second root, and then only touch it and go back way up, back up. Something like this. Yeah, that's a general sketch. Okay. Yeah. You know, because of this part where there's imaginaries, I'm thinking there might possibly be some other undulations to that, but at least close to the graph, that's going to be what it looks like. Just out of curiosity, let's see what this looks like. X squared plus 9. Here. X squared plus 9. Oops. And then, what was the other ones? X minus 3 squared, x plus 1 to the 4th. And then x, what, shucks, plus 1 to the 4th, was it? Okay, wait. X plus 1 to the 4, yeah, okay. So it should cross at -1 and at 3. So let's look at here. Yeah, here's -1, right? Here's 3, yeah. And then this should be 81. Yep, 0, 81. Yeah, there it goes. So actually that turnaround happened way over here at 1,000, 1.8, 1,000. So, but you know, general shape, we pretty much had it. So we have a rough sketch of what it was, and yeah, look, kind of, I mean, really general shape. Okay, looks like the real thing went more high and then came back down, but you know, big picture, we got it. All right, that's it, guys. See ya in the next lesson.